Hello everyone. Today we're going to solve another civil engineering licensure examination MST board problem, and this is our series number 42. Our problem for today is all about age problem. Let us now start solving a board problem. First and foremost, allow me to read the problem. In a film, an actor plays an elderly character criticized for marrying a woman when he is three times her age. He wittily replies, but in 20 years' time, I shall only be twice her age. How old is the actor? And for the start of our solution process, first let us just assume that X must be the uncle's age. And then also let Y be the woman's age. And then afterward, allow me to create three columns also for the characters, present age, and age after 20 years of each character. For the first row, let the present age of uncle be equal to x, and then his age after 20 years be equal to x plus 20. And then also, let the present age of the woman be equal to y, and then her age after 20 years be equal to y plus 20. And since it was also mentioned in our given problem that the actor who plays as an elderly character and criticized for marrying a woman, he is three times her age. Therefore, x is equal to 3y to represent that statement. X is equal to 3y, meaning the man who marry a woman, he marry a woman when he is three times her age. And then afterward, let us try to transpose 3y to the left-hand side of our given equation. That is why our equation will become x minus 3y is equal to 0. X minus 3y equals to 0 becomes now our equation 1. Our next equation will become x plus 20 equals 2 times y plus 20, since it was also mentioned in the given problem that 20 years after the man who marry a woman will be twice her age. And then afterward, in our given equation, in this given equation, at the right hand side, let us distribute 2 to y plus 20. After multiplying 2 to its term of y plus 20, our equation now is x plus 20 equals 2y plus 40. Simplifying our equation, it will now become x minus 2y equals 40 minus 20, because in this situation, previously we have transposed 2y to the left-hand side. That is why it will become negative 2y, and 20 from the left-hand side of the equation previously was actually transposed to the right-hand side. That is why again, I will read the equation x minus 2y equals 40 minus 20. Finally, this is now our equation 2. X minus 2y equals 20. We can then now start solving for x. In order to start solving for x, let us just use equation 1 first. Using equation 1, x minus 3y equals 0, we will be transposing minus 3y to the right-hand side of the equation. After the transposition process, x now is equal to 3y. Solving for y now is equal to x over 3, and let it be our equation number 3. Let us now try to use equation 2, and our equation 2 is x minus 2y equals 20. After the transposition process, our equation now is x minus 20 equals 2y, and so that we can solve for the value of y, let us all divide each term by 2. And now we have 2y over 2 equals x over 2 minus 20 over 2. Let us now simplify our equation. Y now is equal to x over 2 minus 10, and let it be our equation number 4. After obtaining both equation 2 and equation 4, we can then now equate both equations. Our equation now will become x over 3 equals x over 2 minus 10. For the continuation of our calculation, we have now the difference of x minus 3 and x minus 2 be equal to negative 10. Simplifying our equation will become 2x minus 3x all over 6 equals to negative 10. And then here, we can then actually cross multiply 6 to the right hand side of the equation and be multiplied by the number negative 10. Negative x equals negative 10 times 6. Since both sides of the equation is having a negative sign, negative divided by negative is equal to positive. If I'm going to divide both sides of the equation by negative 1, the result of our x value will then be positive. Finally, the value of x is equal to 60 years old. This is the age of the actor. And for the value of y, as the woman's age is equal to 20 years old. Finally, our answer to this given board exam problem is equal to 60 years old. This is now the actor's age. Thank you very much, and God bless us all.